You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Tigera provides the industry's only active security platform with full-stack observability for containers and Kubernetes. Tigera's platform, Calico Cloud, delivered as a fully managed SaaS, or Calico Enterprise, a self-managed service, prevents, detects, troubleshoots, and automatically mitigates exposure risk of security breaches.
Another day in Chicago. You know, we sit here at the show floor and I see this guy walking by all the time. He always has like these 3 bags of little toys.
Yeah.
That's the kind of action you get here, you know, at an event like KubeCon. And it's so good to be here with Tigera CEO Ratan Tipirneni. How are you, sir?
Excellent, very well. Thanks for having me here, Alex.
Yeah, we're going to talk about your new security product that you've. It's not new. It's something you've been building for many years.
That's right. Yeah, no, we've been at it for a long time, so we're excited to be announcing it now.
Oh, okay. And so as I understand, really what it is like there's one thing in particular that I wanted to talk to you about is it has a number of features, and it's the Calico Cloud Security Score recommendation. You've also, kind of provided some new features for Windows host process containers, which we don't have to get really into, I know, because we talked a little bit, there's a lot there. And there's the IPv6 support that you have, and the enhanced observability with VXLAN. And so why don't we start with the recommendation engine? I'm a little skeptical of recommendation engine, so maybe you can help convince me of why it makes sense.
Yeah, so, before we get to the recommendation engine, let me step back and tell you a little bit of the motivation and the genesis for that. So we've been in this market for several years, and, I've been coming to KubeCon for 6 years. And one thing is that the profile of the buyers has changed significantly. Early days, 6 years ago, we used to see really the visionaries and the deeply technical early adopters. The good news is Kubernetes has started to become more mainstream, which means some of the early majority users are starting to kick in. And one of the pieces of feedback we've heard from them is the complexity around both Kubernetes and the security associated with Kubernetes. And one consistent ask we have received from customers over the last 3-4 years especially is, simplify this whole thing for me, tie all the pieces together, and give me a simple summary of that. So that was a little bit of the driving philosophy behind what we designed. And the security within containers, Kubernetes itself was very siloed. So what we decided to do was to stitch 5 elements, critical elements of security together into a cohesive whole and present that to a user in a simple, easy to consume manner, and that was the philosophy behind that. And really the 5 things, if you're wondering what those are, there's a vulnerability score, so the images itself, there's a configuration hardening that is involved, and then there's a runtime security, and then the network security and the observability. And these 5 solutions in the last 6 years have grown up in silos, but what we decided to do was to stitch all those together and present a cohesive picture to a user about how his or her cluster, Kubernetes cluster, is doing from a perspective of security. How secure is it? In a simple framework, scale of 1 to 100, how secure is that? And that's really the genesis behind the security score, and more importantly, the trending. Is it getting better or is it getting worse over the last month, over the last 3 months, over the last year, so that people understand where they stand, and then comes something actionable. Like, what do you do to actually improve the score and move the needle in the right direction? And that's where the recommendations engine comes in. So there's a lot of work that went behind that, but we decided to make the interface itself extremely simple, easy to use, and plug and play.
So when you combine these five subject matter areas, then how do what did you build? What did you build? How, what is it that you developed. Tell me about the development of the algorithm itself.
Yeah, so the algorithm itself is quite sophisticated, but let me give you some examples to highlight that. One of the big areas one of the big attributes that increases the risk profile of a Kubernetes work environment is how you're handling egress traffic, whether you have the right egress controls in place or not. Because workloads are dynamic inside a Kubernetes environment, it's very difficult to establish egress controls using traditional legacy security tools. So as a simple matter of fact, do you have those security controls or not, right? That contributes to how secure your cluster is. Another example is one of the most effective ways to actually prevent the spread of ransomware is to actually establish workload isolation. And so do you have that in place or do you not have that in place, right? That's another measure of how secure your cluster is. So those are two simple examples. The third example I'll give you is, maybe 3 or 4 years ago, it was good enough to be able to spit out the vulnerability scores on a CVS scale of 1 to 10 of how many images you have and what their scores were. But what customers are saying is that's not enough. They want to understand the runtime behavior about which of those images are actually being invoked at runtime, and that really drives the risk profile of a security cluster. So that's another example of what we're baking into the security score.
But what about accuracy? I mean, this recommendations are only as good as those algorithms are, right? And you could get incomplete data. You could get flawed recommendations.
You're spot on, and that's why it's really critical to understand the actual flow of data across the network between these microservices. And that's the foundation we use, and that's why we're uniquely positioned to build something like this. So we're not guessing any of this. Everything is built on empirical data. If the blue services are talking to green services, that's factual data, right? And we're actually building a lot of the algorithms and our heuristics based on observed behavior as opposed to anything that we're projecting.
How do you also then, make sure it doesn't miss something, like a misconfiguration, for example?
Yeah, so we've actually over a period of time we've collected all the controls that need to be in place. And this is mostly about ensuring that all the right controls are in place and do it in an automated way. Because most of the time, if you're relying on something manual, that's when you're likely to miss something. And we've just been able to cumulatively catalog all the necessary controls from a configuration best practices perspective, and it's automated. But more importantly, it's not enough to do that. You have to be able to raise the profile of something if something is missing. And to bake it into something like a security score, if there's one metric, one dashboard a user can come in every day and look at it, and if they're seeing a trend in a downward direction, it gets them to actually take action. So this starts to bleed into the behavioral element of that, and that's the last mile we're trying to plug.
So I'm asking lots of questions about these recommendation engines because I'm curious about them, but there's also the matter of you could tell really good recommendation engines by how filtered the answers are, right? And the tough ones to use are ones that are overwhelming. So how do you prevent information overload?
That's a great question and a great point. I think the approach we have taken is, first of all, to make the recommendations extremely simple and granular and actionable. So let me give you an example of that. So one of the recommendations may be that you don't have controls to prevent blue workloads from talking to green workloads, and you need to establish a control to do that, and click here to actually do that. That's an example of a very specific recommendation, and it's very granular, it's actionable with actually some automation behind that to actually enable the user to do that. So that's how we made sure to do that, and we've actually sorted that, instead of throwing a whole load of recommendations at a user, we try and restrict it. The second thing we have done is we actually give the user a rationale for the recommendation of why did we arrive at this recommendation? In case the user wants to look at a flashcard and say, okay, why did Calico Cloud make the recommendation? We actually have a rationale behind that.
Let's move on to another topic. How about we move on to eBPF? And I'm curious about this question about IPv6 support for Calico's eBPF data plane. Maybe you could explain for the people out there who may not be familiar with a little bit about the eBPF data plane and why you're providing support for IPv6.
Yeah, so eBPF is a new kernel technology that surfaced. It stands for Extended Berkeley Packet Filter. Very powerful technology that allows you to peek into the kernel. It adds some functions to kernel functions and watch some of the data. So we invested very early, starting several years ago in eBPF. A lot of work we do, both in networking, security, and also observability, leverages the eBPF technologies. And we were one of the early pioneers in that. And we now have customers using that at scale. We had a number of customers users stop by yesterday at the booth, and we were pleasantly surprised with the scale at which they're running Calico eBPF, and there are tens of thousands of nodes. And so that's the background and the history behind that. And one of the pieces of feedback we've been hearing is just the issue around IP exhaustion with IPv4, and that was really the driver for going and building IPv6. And it's been something that the community has been looking forward to, and we're very excited to be able to announce that.
So, with IPv6, doesn't it? I hear this a lot. It can really kind of increase the complexity of operations, And so what are what would be your counter argument to that, where it's just basically a lot of work, and like a very complex for people, and there's actually not many people who are as necessarily familiar with IPv6,
Complex. So Alex, can you clarify the question? The complexity for, you're saying?
Managing both of them. So managing both IPv4 and IPv6.
Yeah, so it's a little bit of a trade-off. Obviously, with IPv6, you get the benefit of a bigger pool of IP addresses. You're not going to run into the exhaustion. At the same time, you can't really cut over because you've got some investments in IPv4. So that's a little bit of a trade-off users are going to have to make, and there isn't really like an easy solution for that.
But the need is there. How are you seeing it?
Yeah, no, the need is there, especially for customers who are running things at scale, or maybe they had some practices in the past that was suboptimal in the use of IP addresses, and they're running out of IP addresses. So it's a forcing function to switch to IPv6.
How do you take into consideration issues such as maturity, right, of the technology itself? With IPv6 in particular.
Yeah, I'd say, in general, I'll try and give you a general response, articulating our philosophy on that. We're always working on the bleeding edge of technology. Yeah. However, philosophically, one important thing for us is never to force it on customers. We always want to give customers a choice instead of forcing them down a path. Because as you're probably alluding to, anytime you have bleeding edge technology, it does come with risk, right? And that's one of the reasons we actually made an architectural decision to design a pluggable data plane, because not all customers are very comfortable with the risk of adopting the latest technology. And we want to be able to empower them to be able to do that at their own pace. And so that's the approach we take to everything we build.
Let's move on to this concept of centralized management for security. And, this is very much a centralized security platform that you're offering. And, it does have its advantages in many ways, Maybe you could list those, because I have a few questions about what might be some of the disadvantages.
Yeah, I'd say so. First, this again is a requirement we're hearing from customers. So again, it'd be helpful to step back and understand what's driving it. So what customers have seen over the last few years is a little bit of a cluster sprawl, where users have been spinning up clusters on-prem, in the cloud, in different clouds. And suddenly there's a need, you wake up one day and you say, you got these hundreds of clusters spread out across different pieces of infrastructure, and how do you establish security controls on them, and how do you manage them, right? And so that's really what drives the need for some level of centralized management. And there's the cost element, right? You can't have multiple people managing these multiple platforms for different platforms. It's just not, from a cost perspective, that's not feasible. So that's a little bit of the driver. And the other part really is that whenever you have multiple interfaces, it's prone to manual error. So you want to try to centralize all this really in one place, single pane of glass that enables you to switch across clusters, set security policies, set compliance controls across different clusters in different environments. So that's really the driver for that. And the second part really is what I touched upon earlier, which is a lot of these security solutions grow up in silos, and the need to bring all that together into a single place was also very, very important. Because again, these were extremely splintered. It was very difficult to get a single view of your vulnerability management, your configuration management, your runtime security, your network security, your observability. Those are 5 tools. To be able to centralize all that and to actually be able to manage multiple clusters in multiple clouds or on-prem is an extremely powerful value proposition.
So the question I then have about that are things like single point of failure. Is that an issue? The complexity that comes with that. A little bit of, the concern, how do you kind of if I'm an end user, how do I stay on the cutting edge of observability tools, right? By moving to a centralized platform. And then there's just the general, I think concern that we see in the market is just this really then almost makes it a requirement to think about platform engineering in a way too.
Yeah. No, I picked up 4 questions there, so let me try and tease those apart. Yeah. I think the first question you had was in terms of the complexity, right? Yeah. And that's a real problem. So our design philosophy, we actually made a commitment about 3 years ago to make everything we do plug and play, right? So literally everything is extremely simple to use. A lot of stuff we do under the hood, it could be very complex using eBPF, but we actually hide all the technology, all the complexity from the user, make it very easy to use. If you look at our design, we hired a design firm to make it, we invested to make it extremely simple to use, and that's really started to pay off, especially as the buyers have started to change. I think the second question you had was single point of failure. That's a good question, and what we have done is, we have a Kubernetes solution, right? So by virtue of that, we have built a little bit of HA into our solution itself.
Wow.
And that's one of the big differences when one of the legacy vendors claims that they're supporting cloud native workloads. That's a good question to ask. If they've taken a firewall, put a little bit of lipstick on the pig, and they're trying to pretend that it's supporting a cloud native solution, the HA is a good question to ask, because if your solution itself is not cloud native, if you can't scale based on real-time demand, right there is a good proof point that you may not be ready for prime time there. I think the third question I heard you ask was observability. And observability is a broad spectrum, but in the context of what we do.
And new tools, how locked in are you? So, if you want to use new tools, can you work with the platform to integrate those?
Absolutely, and that's a core part of our design philosophy. Everything we have built, we made sure it is modular to align with the core Unix philosophy. and that we expose APIs, because like as an example, we have a service graph where we can actually demonstrate the flow logs and how different services are interacting with each other. But some customers may actually have a very sophisticated SIM where they've baked in some processes and wrapped some processes around that. Maybe they just want to take some of the data and actually move it into their SIM. So we open up APIs to everything we do, and we've made it very modular so that for a platform engineering team, if they want to integrate some parts of it with their existing tools, existing workflows, it's very easy to do. On the flip side, what we are seeing more and more of is teams that are struggling with the complexity, to your earlier point. They want something easy to use. They want everything in a single box. So out of the box, this thing just works.
Thank you so much for your time, Ratan. I really appreciate it.
All right, thank you, Alex. Pleasure to be here.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.